Hey guys, welcome back. So what we're looking at today is 1.2 Ready, Set, Go for the name of it is Growing Dots is the name of this lesson. And like I said, we're looking at the Ready, Set, Go, so let's go ahead and jump right in. So what we're looking at here is using function notation. So to evaluate an equation such as y equals 5x plus 1 when given a specific value for x, we replace the variable x with the given value and work the problem to find the value of y. It's going to give you an example here. So to find y when x equals 2, replace x with 2. So we have y equals 5 times 2 plus 1, which equals 10 plus 1, which equals 11. Therefore, y equals 11 when x equals 2. So the point 2, 11 is one solution to this equation. And so instead of using x and y in an equation, mathematicians often write f of n equals 5n plus 1 because it can give more information. With this notation, the direction to find f of 2 means to replace the value of n with 2 and work the problem to find f of n. The point, n f of n, is the same location on the graph as xy, where n describes the location on the x-axis and f of n is the height of the graph. Excuse me, sorry. Okay, so basically what we're looking at here is function notation. So we have that f of n, so don't let that confuse you. Having f of n is just like having y, same with having g of n. All it represents is that for whatever variable it has in there, so in this case, it's saying f of n, so our variable is n in each of these cases. For that variable, if we replace a number in there, for that number, that's what we're going to take and replace our variable with in the equation. So function notation makes it a little easier to say, hey, we want to substitute the variable in this equation with this number. It's a little easier than having y equals something and then having to say, oh, and x equals such and such. Makes it a little easier. Okay, so we are going to look at problems 1 and 2, just so you can see them both. And so for number 1, it's saying f of 5 equals what? Well, in order to do this, I've got it on my whiteboard, and I'm going to make myself bigger here in just 1 second. Because it is using the f for the function, that means we're going to use the 8n minus 3. So we're going to have 8n minus 3. And so now we know f of n, 5, so we're going to place the n with 5. So we're going to have 8 times 5 minus 3. 8 times 5 is 40 minus 3. And that would equal 37. There's our answer. So when you do this, nothing happens with this f of 5. It doesn't get included in the equation when you're working it out. You don't have to subtract anything. You don't have to try and get rid of that 5. It is completely separate. You're working through this portion of the equation. You don't have to worry about the f of n part. Okay? All right. The next one, we have g of 5. So the g tells us that instead of using the f of n equals 8n minus 3, we're going to use the 3n minus 10. So we've got 3n minus 10. Once again, we're substituting 5 in for the n. So we've got 3 times 5 minus 10. 3 times 5 is 15 minus 10. 15 minus 10 is 5. So there's our answer. So plugging 5 into both of these functions, and yet we get two very different answers. So for each one of these, it's going to have you plug the same number in for n in each of the two functions, just to show you the differences between them. So be careful, make sure you're plugging the right value into the right function. So if it's got f of like the next one, -4. Make sure you're plugging that -4 in to the f function. Oh, so sorry. All right, so the next thing we're looking at, right down here, we are looking for patterns of change. So we have the term number, so first, second, third, fourth, fifth, sixth, seventh, eighth. So we've got all these terms, and then we've got the value. So the first term is 2, the second term is 4, third term is 8, fourth term is 16, fifth term is 32. So what this is what's known as a sequence. Sequence is your key word for this lesson. Sequence is your key word. A sequence is just a series of numbers that have some sort of pattern to them. So it might be you're adding the same number every single time, or you're subtracting the same number every time, or you're multiplying by the same number every time, or you're multiplying by a fraction, which would be the same thing as dividing. You want to think of it in terms of multiplying by a fraction, though, rather than thinking of it in terms of dividing, because when it comes to writing equations later, having the fraction is going to be easier than having the division. So try and think of it in terms of multiplying by a fraction. So if we look at our sequence here, we're going from 2 to 4, 4 to 8, 8 to 16, and 16 to 32. Are we adding the same amount every single time? No. Are we subtracting? Definitely not, because we're going up in our numbers. So that means we also aren't dividing. We're multiplying by a fraction. Remember, we want to think of it like that. And so that means we are multiplying each time. Now, what are we multiplying each time by to get from 2 to 4, 4 to 8, 8 to 16, so on and so forth? We're multiplying by 2 each time. So that means to find our sixth term, we're going to multiply 32 by 2 to get 64. And then for the seventh term, same thing. We're going to take 64 and we're going to multiply it by 2. So that's going to give us 128. And then for the eighth term, same thing. We have to take the previous term and multiply it by 2. So we're going to take the 128 and we're going to multiply it by 2 to get 256. So that is what you're looking at here. So these sequences, you're looking for the pattern. So whether it's adding or subtracting, multiplying or multiplying by a fraction, which is like dividing. Okay, so that's what you're going to be looking at in here is for that pattern. All right, so the next thing we're looking at here is in the pictures below, each square represents one tile. For number 13, we want to take and draw steps 4 and 5. So this is using variables to create equations that connect with visual patterns. So we're looking at this visual pattern. I'm going to do it here on my whiteboard because it's going to be a lot easier than trying to draw on there. So if we notice, step 1 is just a single box. Step 2, we still have that single box there in the middle, but now we've added one box on 3 of its sides. Step 3, still have the box in the center, still have the 3 boxes that were added, and then we added one more on each of those sides. So for step 4, once again, we're still going to have the box in the middle, but notice step 3, we had 2 boxes on either side off of the center. So for step 4, we should have 3 boxes. So 1, 2, 3. Same thing to this outside. 1, 2, 3. And then same thing up. 1, 2, 3. There is step 4. So just continuing to follow that pattern. So we're adding 3 new boxes each time, one on each of the 3 legs of this figure, essentially. All right, so then step 5, same thing. We've got our center. And then step 4 had 3, so step 5 should have 4. So 1, 2, 3, 4. And then this is our center, so 1, 2, 3, 4. Then we go up. 1, 2, 3, 4. So we could keep going on and on with this pattern. Luckily, we don't have to. We just had to do steps 4 and 5. But we are able to take and look at these patterns, and we could take and create equations based off of these. So the next thing that we're going to take and look at, I'm going to do one of them with you just because I want to see you guys get some practice with them as well, is this next little part right here. So let's read through it. The students in class were asked to find the number of tiles in a figure by describing how they saw the pattern of tiles changing at each step. Match each student's way of describing the patterns with the appropriate equation below. Note that S represents the step number and N represents the number of tiles. So we have our different equations. So we have A is N equals the quantity 2S minus 1 plus the quantity of S minus 1. For B, we have N equals 3S minus 2. And for C, we have N equals S plus 2 times the quantity S minus 1. So we've got 3 different students here. We've got Dan, Sally, and Nancy. So Dan explained that the middle tower is always the same as the step number. He also pointed out that the 2 arms on each side of the tower contain 1 less block than the step number. So we're referring to what's going on up here. So the middle tower, so in step 1 we only have the 1 square, so it's not very helpful. Step 2, this middle tower here has 2 boxes in it, and it's step 2. And then the arms on either side of the tower contain 1 less than the step number. There's 1, there's 1. Let's look at 3. There's 3 to the tower, 2 on this arm, 2 on this arm, which is 1 less than the step number. So that means equation C represents Dan's situation in how he's thinking about it. So what you guys are going to do is read through 15 and 16 and figure out which one is can be represented by equation A and which one can be represented by equation B. And use the steps from up here, from our tiles and everything, and the ones that I did for 4 and 5, hopefully you wrote those down, use those to help you as you pick which equation goes with which situation, okay? All right, our last section is dealing with exponents. So we want to write each expression using an exponent. So with exponents, we have a base number and we have the exponent. The base number is the number that's being multiplied all the times. So if we look at 17, the base number is the 6 because that's the number that's being multiplied together each time. So we're going to write a big 6. Then we take and count how many there are. So 1, 2, 3, 4, 5. So that means that for our exponent, we're going to do 6 to the 5th. That's all you have to do in writing an expression using an exponent. It looks just like this. Base number, which is the one that's being multiplied all those times, to however many there are. All right, the last part. Write each expression in expanded form. This up here is expanded form. And then calculate the value of the expression. So we're actually going to look at number 28. So to write this in expanded form, we're going to start by writing the 16 times. Now, 1/2 is our base number, so we write it times, and there's supposed to be 3 of them. So 1, 2, 3. Now, if we take 16 times a half, what's half of 16? Well, that's 8.